Another DraftPhysics.com video presentation. So, some of the critics, some comments we'll go over. DraftScience has made a video about the ferrocell, which I have mentioned a lot recently as an example of shenanigans physics kind of stuff where experiments are really deceptive. And the ferrocell is a great example because it doesn't even come close to showing you the underlying truth. It will deceive you if you're not. You have to do some thinking about how it works. If you're just shown it, it's dramatic in its demonstration, but it's wrong. And I'd say it's very similar to the Clay experiments done to validate the kinetic energy theorem. So we'll deal with a comment regarding that first, and then we'll go on to DraftScience's video, which I thought was very poor because he decided to use his opportunity to explain a lot of things that aren't an issue in terms of the misunderstanding. It's not people's misunderstanding of magnetic moments of electrons that is fooling them. The mistake is much more basic in terms of understanding the path of the photons and what they're bouncing off of. And that's what the experiment is really about, the device. Anyway, okay, in today's video you mentioned double the velocity of a falling object would have to drop it 4 times the height. So it's just a fact, and it doesn't matter how heavy or light the object is. So it can be the Earth, right, and an atom. And the fact is, to make the atom go twice as fast as the Earth, I have to lift it 4 times as high in the gravity. Everything drops at the same rate in gravity, and the dropping rate acquires the same velocity from gravity. So gravity is, it compensates for your mass in a sense. I don't want to use the word compensate as if it needs to. It's just the fact that the sail is as big as your mass, and that's how much wind you catch, and that's how much total energy you use is how much wind you catch. So gravity is like a wind, your mass is the sail, and to gain this, to double your velocity, you have to go 4 times the distance in the wind to do that. You can't just double it by twice the distance, because the amount the wind is pushing at each moment is not as big, okay, as the amount of your acquired velocity. You accrue velocity like interest is, I'm actually going to argue. I'll actually make that point in my response to him. But anyway, all right, that is also 4 times the work to lift the object to that height. So this one is this is the classic for me, because yes, I've played the Professor Lewin video where he's holding a briefcase. And he says, I'm not doing any work. Now, by a mathematical theory, you could say you're not doing any work in the sense that you're not accomplishing anything. You're not moving the briefcase anywhere. But the fact is, holding it is doing work. So there's no way you could say you're not doing work, because the fact is your body is doing work to support the briefcase. Okay, so if you were a spring, you would be compressed. You would be demonstrating that energy was involved in the sense that the spring would compress, showing that you're doing work, even though you're not going anywhere, even though you haven't moved it 4 times higher. You didn't move it anywhere, and you're still doing work. So that's just a poor understanding of what the idea of work is, okay? And the fact is gravity does impose it. So the premise you're arguing from, I would say, is incorrect. All right, so it says, that is also 4 times the work to lift the object to that height. Now, it's only 4 times the work if you lift it slow, okay? That is slower than gravity, okay? So if you lift it at a rate that's very slow, and we all have this experience, if I lift something very slow, it seems like a lot more work than if I can lift and jerk, right? Weightlifters can lift a lot more weight if they jerk the weight, okay, rather than slowly lift the weight. If they slowly lift the weight, they don't have a chance. But if they can create some velocity and gain the benefits of velocity over the gravity, they can defeat a portion of the gravity and therefore make the weight actually lighter. And they have to do less work. So if you can gain velocity above 9.8 meters per second, then you can gain distance, okay, without doing any work, because your accrued velocity will do the work for you. All right. Anyway, I'll read it again. That is also 4 times the work to lift the object to that height. So I'm arguing that it's only 4 times the work depending on how you lift it. So if you lift it very, very slowly, it's 1,000,000 times the work. If you lift it very, very quickly, it's a lot less work. If an object of 1 pound is dropped from 1 foot height, that is equal to 1 foot-pound of work. Okay, fine. So you're going to use something besides joules. That's all right. That probably in some ways relates to a joule in the sense that now you're getting to this 3 number, 3.2, and if you discount your weight, then it's my 2.3 number for the conversion of momentums into joules. So you're pretty close to that when you're saying a foot, which is 1/3 of a meter. You start going through this to find the equivalency. So you're basically saying a joule. A pound is 4 times as much as a newton, blah, 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 blah. To raise it to the 4x height is 4 foot-pounds of work. It's only 4 foot-pounds of work, okay, if you lift it at the rate of gravity. That is, it's slower, at 9.8 meters per second or slower. If you lift it slower, it's more work, because you have to work to just suspend it. You're doing work. Okay, hence why the energy recovered has to be squared, or the energy should be, or energy would not be conserved. So that's just because you've wrongly estimated the amount of energy it would take. When you're dropping it, it's accruing velocity. So obviously gravity's not doing as much work. Gravity is only doing a little pushing, per a unit of time. It's only a certain amount of gravity falling, blowing. There's only so much wind to catch. Okay, and if the object's moving faster than the wind, okay, then obviously it can gain distance kind of for free. And so when you naturally drop something, it isn't moving at 9.8 meters per second. It moves frankly, it only moves 5.4 meters in the first second. So it doesn't even move at its rate of velocity. It's moving so much slower than its rate of velocity. But the point would be is that as it accrues velocity, it covers distance much more rapidly for a tiny more increase provided by gravity. The last second of, let's say if I have a meteor crashing into the Earth, right? The meteor can go 10 miles an hour when it's far away, and the little push by gravity means a lot in terms of adding velocity. But as it gets closer and closer to the Earth, and it's going, say, 10,000 miles an hour, the little tiny push by gravity means nothing, because it just means it'll be going 10,000.001 mile an hour. I mean, it'll be a tiny increase to its total velocity. So it's just about a meaningless contribution. So your accrued velocity is what's doing the work. And the accrued velocity, as we know, is sort of perpetual motion. It can resist forces. So anyway, to an extent, you can certainly. It doesn't. If you're going with a force, it's obviously not going to lose any velocity, and you're going to cover a lot more distance than the force is pushing you. Is the point? All right. So I'll try to simply draw it. So this goes back all the way to the 1600s. I think smart people should be able to understand. People have some scientific literacy. That people are just getting confused about how gravity works. So the understanding would be is that you're traveling a distance, and the key thing is there's measuring time, and then there's measuring the distance you go. And the idea is gravity, okay? Does gravity care about how much distance you're covering, or does gravity have more to do with how much time you're in the gravity? So I've used the example of catching rain in a bucket, okay, and that's really all that matters. It doesn't matter how fast you're moving. So if I made it a movement in this direction, just thought of a bucket and it's raining, it's not going to matter how far I travel, how much rain goes in the bucket. It just matters how much there's a rate, okay, of the stuff is falling at, okay, and that rate doesn't matter whether I cover 10 miles, okay, or I cover just 1 mile. As long as the time is the same, I'm going to have the same amount in my bucket. So if it's falling this way, you know, and you're going this way, you can sort of understand that it just doesn't matter how much distance I cover. I'm still only going to collect the same amount because it's completely time dependent. It's a rate at which it's falling. And gravity works the same way. It falls at a rate, and it doesn't care how fast you're going. The same rate of rain will fall into your bucket because the bucket's moving infinitesimally, tiny amount compared to the speed of the actual rain. So the rain's moving the speed of light. You're moving some stupid velocity that's just almost insignificant. It's so tiny by comparison. So no matter what distance you travel, you're going to collect the same in the bucket. So the amount of work, that is the amount of gravity contributed, is always going to be the same. So if I'm going fast, if I gain velocity above the rate of the falling rain, then I'm going to cover huge amounts of distance, okay, but I'm only going to collect in that huge distance the same I collected in the tiny distance of my first 5 meters per second. So the first second, I'm only going 5 meters. I only covered 4.9 meters. In the last second, I'm going to cover maybe 25 meters, if it's 4 seconds worth. So, that's the difference. So when you launch an item, something with a higher velocity, that is the velocity it landed with. If I drop something, further than, if I drop something, the fact is that it accrues this extra velocity that's faster. Its velocity is faster than the distance it's covering as it's accelerating. But if I'm going faster, if I have finally passed going 9.8 meters per second, as soon as I pass going 9.8 meters per second, I'm gaining all kinds of energy efficiencies in that I'm able to travel more distance without using a lot more energy. So if you launch the item at 22 miles an hour, okay, it will land with 22 miles an hour, versus 10, but you're only using twice the energy. It's only twice the energy to launch it at 20 instead of 10. It is only twice the energy. It's not 4 times. Yes, you go 4 times higher in gravity because you're going faster, twice as fast actually, as the gravitational force is pushing against you. So you have to go 4 times higher to be able to fall, to hit the ground at 20 miles an hour again. Because you have to wait for yourself to get accelerated from 0 again. So you have to go 5 meters in that first second. And then you have to go 15 meters in the second second. And, blah, 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 blah. You have to obey the rules of the gravity. So I'm just saying, yeah, it's a little convoluted, gets a little tricky to understand the difference between time and distance. But any good scientist should know distance could be a real dodge. If you're going based on how fast something moves, you would think that, oh yeah, the gravity near the Earth is incredibly strong because everything's moving so fast when it's close to the Earth. Well, no, it's not moving fast because it's close to the Earth. It's moving fast because it's been gaining velocity on its whole trip. And its accrued velocity is what's making it go fast, not the little addition from gravity. The little extra push from gravity almost means nothing. When it's going 10,000 miles an hour, 9.8 meters per second isn't going to make much of a difference. And that's just the truth. So that's what fools you. It's not 4 times the energy to lift it. It's only 4 times the energy to lift it if you lift it too slow. If you lift it as fast as gravity will throw it back at you, if the launch speed is the same as the crashing speed, okay, then the energies is you're just doubling. You're not quadrupling. You want to double the velocity. You go 4 times higher, but you're not getting 4 times as much work to do that because you started at 20 miles an hour to get it 4 times higher. You didn't carry it 9.8 meters, 9.8 meters, 9.8 meters, 9.8. You didn't do it that way. If you do it that way, yes, it's 4 times the work. If you do it as gravity will throw it back at you, which is going 20 miles an hour, then it's only twice the work. All right. Like I said, it's hard to do a perfect, concise description of this subtle complexity between distance and time. Gravity falls at a rate. Gravity pushes you at a rate per unit of time. It doesn't, distance is just not relevant. It's just a bucket collecting something. All right. Equal to 1 foot-pound. Raise it 4 pounds the height, 4 pounds the work, hence why. Okay, so we already did all that. So I said to it. That is also 4 times the work to lift the object to that height. I says it's only 4 times the work if you do the lifting very slowly. If you lift it faster than 9.8 meters per second, that is the natural fact that gravity will throw it back at you with a much higher velocity, you will gain distance without doing any work against gravity. So that's the simple point is that the distance will be covered more efficiently with the higher velocity. Gravity falls at a rate per time. It doesn't fall over a distance. So if you run fast enough, you can miss banging into it. So I'm trying to analogize it to something, but that's sort of the idea. Is that you can evade the gravity by getting through it more quickly. It's probably not a great analogy. Gravity is something like friction. The faster you go, the less of it you have to work against over a given distance. So again, but the distance is really irrelevant because the only thing you're using the distance to do is shorten the amount of time. So by shortening the distance, by going faster, you're shortening the amount of time you're being exposed to the radiation, so to speak. And the less exposure to the radiation is the less work you have to do to fight it, so to speak. To raise it to 4x the height is 4 foot-pounds of work. This is only true if you're using a constant force to lift it. That is, if you're lifting it at a slow rate, a slow, constant velocity. If you lift it with a high velocity impulse of energy, the same velocity the object would fall with in gravity, that is higher than 9.8 meters per second, you will only be doing twice as much work. So to lift it, even though you went 4 times the distance, you only used twice as much energy because your velocity gave you a huge advantage in escaping the time you were exposed to the gravity. Okay, anyway, I suppose it could be said that velocity accrues interest with distance. The fact is that the 4 times the height is only twice as much time. So if you shoot it faster, it's only twice as much time. If you shoot it even faster, it obviously won't stop at the place you want to stop at. It'll go much more than 4 times higher. But if you use the higher velocity, the fact is you'll get to that point, whatever the 4 times higher point, even faster, and you would have done even less work because you wouldn't have been in the gravity very long. All right. You can only do work while you're in the rain. Okay, and so the shorter amount so if you shorten the distance by increasing the velocity, that is the time you're making the distance. Anything that shortens how long it takes you to draw the line means you're exposed to less force that you have to work against. Okay, I suppose it can be said that velocity accrues interest with distance. So, interest is a useless word to use in the modern era because there is no such thing. But in the old days, you could put your money, in the bank and it would gain velocity. Okay, it would grow. And the grow was free of work. And velocity is like that in gravity. Velocity gives you the ability to cover distance without having to do work because you're evading the time you're exposed to the force. All right, momentum energy is conserved and work can only be sensibly understood as a transfer of velocity to a mass. So momentum energy is what I'm arguing. So he says our energy would not be conserved. Momentum is energy, okay? It is conserved, and the work can only be sensibly understood as a transfer of velocity to a mass. So you're only doing work when a force or an object, okay, is interacting with you and imposing its velocity on you. That is, imposing its momentum on you. That's the only time the interaction can mean anything, is when you're transferring momentum. I'll do another video on this time versus distance versus matter moved what speed problem. So you can't really understand it by just thinking about time, and you can't understand it by just thinking about distance. You just have to really think about it in terms of interaction, and that if the interaction isn't, the longer the interaction, the more complete your ability to, you can't pour the gas in the tank if you're not connected to the car long enough to get the gas in the tank. These kind of rules apply. So anyway, yeah, that's probably enough of that. All right, so I'll switch to the other comment. All right, should be back. All right, so anyway, yeah, so he did like a 15-minute video. He's promising a second part. Apparently he made the video a month ago and didn't publish it for whatever unknown shenanigans reasons. I don't know, who knows, but whatever. So it's published now for whatever reason. So again, I could play the video, but there's no point, because it's just basically the generic magnetic moment theory of magnetism, a bunch of crap about how magnets work that really doesn't have to do anything to do with the elements of the misunderstanding about what the ferrocell is producing and how it's producing it, I would certainly argue. So I don't know if there's much to go in. Okay, I'll go into a little bit of the theory. Just the part that's important to understanding a distinction in the ferrocell. Okay, that wasn't in his video, and it's a really important, in my opinion, very important to understand that iron filings aren't a natural view either. Okay, so the ferrocell is not giving you the right view of a magnetic field, and neither is iron filings, because iron filings, you're cheating, right? You're putting a surface, here's your magnet, and the ferrocell is usually configured this way, north, south, in terms of how you're viewing the magnet. So it is a little different in what kind of pattern you get depending on which way you put the magnet. But anyway, so with iron filings, you're putting a magnet and then you're forcing, essentially, right? So it's more like this. You put the magnet in this kind of direction, and you're forcing the iron filings not to be able to go where they want to go. So they're stuck in friction. Okay, so you end up getting this pattern, this classic kind of pattern, where you'll get, this kind of stuff, like there's stuff going around and around and around and coming out both ends and blah, 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 blah. And I would argue that this fooled Faraday, and it's just, frankly, it's just the wrong way to look at it, and there's a better way to understand what the magnet's doing. So anyway, so these iron filings are stuck here, okay? They wouldn't stay here. If you did this in a fluid, what happens is each one of these makes a choice, and it goes here, or this one goes over here. Okay, so you won't get this pattern. You won't get much of it. Okay, you only get it at a great distance from the magnet, because the fact is the stuff will have enough energy to move. If it's free to move, what it does, it creates this pattern. Okay, if it's free to move, if you do it in a suspension of an oil or something, this is what you get. You get this. Okay, this is the pattern you get on both sides of the magnet. You get this. Okay, little hairs and then big, big hairs here. So you get essentially what you'd expect if it was light bulbs. If this was a red light and this was a blue light, you're just getting radial pattern going straight out of the magnet. Okay, and you're getting very, very little of this over here. Like I said, at a great distance, you might see some stuff lining up a little bit. But the fact is, everything will be a little bit more this way than this way. And so everything's, if it's free to move, this is going to move here. It's going to line up like that. If you have a little square piece here, the little square piece is going to move like that. And so everything's just going to end up being this. This is what you see under a microscope, under the ferrocell. You see these straight radial lines coming off the poles. Okay, so if you put a single pole face down, okay, if you put it like this, north side, you'll just get this. You'll just get a sun, a radial pattern, coming out of the magnet just like this. So that's what the particles are doing. They're just lining up lengthwise this way. Okay, and they're all lined up because it's an opposite magnet essentially, right? So all of these lines become magnets themselves. All the magnets are lined up, and this becomes the north end, and this becomes the south end, and this one has a south end and a north end, and that's why they're separate from each other. So that's why they end up being separate rays, is because the rays are actually repelling each other. So that's the important mechanical fact to understand. This is what the ferrocell is doing. It's not doing iron filing pattern, because the iron filing pattern, frankly, isn't a natural pattern. It isn't what the iron filings would do if they were free to go where they want to go. I think it's an important little piece of context. And such. Okay. This video was a bit of a disappointment, so this is my comment. I dislike you, but I really hate Ken Wheeler's fake science. The last 3 minutes of your video should have been the first 3 minutes. So in the last 3 minutes, he's explaining some of this mechanical facts, that this is just these little particles of ferrite, okay, that are in purely understandable magnetic field lines, okay. They're doing what it would do in a fluid. Exactly what you would expect it to do in a fluid. Exactly what a real magnet creates. Like say if you take oil and you put iron in it, iron filings. You can get the magnet will very slowly, the iron filings will move out of the suspension and clump on the magnet, and you can see this pattern form. But it won't be the classical iron filing pattern. Anyway, it'll like I said, all the bars going sideways will disappear essentially, and all you really have is the spikes coming off the poles. The fluid does that itself. It creates little spikes. If you just pour the ferrofluid on a magnet, it creates little spikes. Well, it's creating little spikes because it's fighting gravity, so that's why they become little mountains, because it's, gravity is pushing the fluid down, so it can't go where it wants to. So again, it's really not the natural view of what they would look like, because gravity is screwing with them. Anyway, the last 3 minutes of the video should have been the first 3 minutes. So the bad part about the last 4 minutes is that it didn't include a couple of the really important things to include, okay, in terms of understanding why this is just light reflecting off these different points. So I've pointed this out in previous video, but what you're doing is you're shining light perpendicular to this iron filing. So it's like you have iron filings on a piece of paper, and let's have them in the spike pattern, okay, and then you're looking at it, you're shining the light at this harsh angle. And so it's almost the same thing as you viewing it at a harsh angle. All of the proportions get screwed up. And what you're really seeing is you're seeing light reflect off of here, light reflect off of here, light reflect off of here, light reflect off of here. And that's what's creating the arced line you're seeing, is the reflections on each spoke are at a different angle because of the direction, the angle. There's a different angle for each spoke. And there's like, say, 33 degrees is the magic angle that's creating the reflection to your eye. So it's 33 degrees on that spoke, 33 degrees here in that spoke. It's on here on this spoke. It's on here in this spoke. It's on here in this spoke. And that's what's creating the line. All right. But he didn't go into those details. All right. More than 4 years ago, I looked at the ferrofluid under a microscope and saw what it was doing, the same thing iron filings would do in a thick suspension. So that's what I observed. And it clearly points out that their iron filings aren't in any position that is at all connected to what you see as the light's position, because you really are making those beams of light, those bars of light, those arcs of light are being made out of millions of different pieces of ferromaterial in all kinds of different places. So it's not, it's like it's a composite image. It has nothing to do with any image that's in the material itself. Okay. Uh, let's see. I've already lost. Under the microscope, and so I was doing the same thing. It's the okay. That is point directly to the poles of the magnet. So that's the part to understand. What's happening under the ferro fluid is not the classic iron pattern. It's more of a radial pattern from the pole or the poles. You should have pointed out in the video that each LED creates one arc of light perpendicular to it. So it's really a key thing to understanding the ferrocell. I should have said it also when just a moment ago, but all it's creating. So for each LED, there's so you have these LEDs going these holes, and if you make a solar one, he still has to put the holes there because it's essential to have the light come through these little holes. Because what's happening is this one creates an arc here, 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 this one creates an arc here. Okay, and that's what's creating the pattern. Each LED creates one arc of light. Okay, so that's all you need to understand. Just count the arcs of light and you'll know exactly how many LEDs there are. Okay, that is point directly to the poles of the magnet. You should have pointed out that in the video that each LED creates an arc of light perpendicular to it, and that the arcs are just precise angular reflections off pieces of the radial spokes coming out of the magnetic poles. So it's just hitting the spokes at different locations, at different angles, and that angle will reflect to your eye. And on each spoke, it's a different place on the spoke that reflects to your eye. All right, the ferrocell is just a sideshow trick, and you should have shown how it mechanically functions. Instead, droned on about a bunch of magnetic theory that isn't much better than Fractal Woman's made-up mush. He mentioned Fractal Woman, so I said, what the hell, I'll throw it in too. So there's a ton of people who are turning the ferrocell into some kind of scientific device when clearly it's exactly the opposite of a good scientific device, because it really doesn't show you. You don't see what you get. You don't get what you see. It's exactly not doing that. So it's only useful as a scientific instrument if you understand just how convoluted and disconnected the fundamental functions are to the actual output. Okay, your model of magnetism is far from reasonable, let alone complete. So he went into a whole bunch of theory about magnetic moments and electrons and all that crap, and it's all frankly, their made-up little story that has absolutely no hard evidence demonstrating that that's actually what are the causes to the effects. And clearly, it's not essential that you have the right story of origins. I mean, as long as you know gingerbread exists, it doesn't matter whether you have gingerbread gremlins or gingerbread elves, right? Any one of those stories will work just fine. But it does matter when you're going to get to something more fundamental, like what makes a brain. And then you figure out, oh yeah, well, gingerbread elves can't make brains, so that's not going to work. Anyway, virtual photons and waving fields isn't just a placeholder for the real truth. It's a silly one to boot. So obviously you can use many worlds to describe the two-slit experiment or Copenhagen or Boresque or Feynman. The universe does play dice. God does play dice with the universe. I mean, you can use any one of those theories and make it work, but you're making it work. You're not actually describing the real function. Okay, anyway, if you don't mind me asking a couple of questions. If a photon's polarization is many hundreds of atoms wide, so he's going to claim he didn't understand these questions, they're incomprehensible, and some other kind of crap. Now, obviously, I can't be concise, and also, if I have to explain to a physicist that polarization is a real thing. So this is what they'll say. When light is polarized, they'll say it does this. Right? It could be polarized that way, it could be polarized this way, it could be polarized this way. So each little photon has a polarization. One could come into you this way, and one could come to you that way. One could come to you that way, one could come to you that way. And clearly what the implication is that if you do this polarization thing with things like radar, you find that there's a very distinct length or distance between bars. So if I'm going to make a polarizing filter, it doesn't matter whether it's blocking it this way or it's blocking it this way. We don't even have to argue that theory. What we know is if I make these bars any closer together, none of the radar gets through. So I have to have them a certain width or none of it gets through, and that's because you're breaking it here. You know, the polarization can't get through the bars either way, because whether it goes in lengthwise or whether it goes in this way, you know, this is the truth, actually. The filter it gets through is actually the filter going against its polarization. You know, it's not a frisbee going through the bars, because it is a composite object, but I'll explain that in some other, I have explained that in some other video. So, yeah, so as soon as I use the word polarization, maybe he's too dumb, okay, I mean, he's too ignorant, I mean, he's too much of a noob to physics, but maybe he doesn't understand. I'm talking about the fact that we know there's a proportion between the wavelength of the radar and this distance. We know that the filter and the wavelength are going to be very close to the same number. Now, maybe not exactly, but close to. So if the wavelength is 3 centimeters, okay, that is 3 centimeters at the speed of light, then this distance of the filter has to be 3 centimeters. You know, that kind of thing. So there's a clear proportion between the width of the bars and the wavelength of the light. So anyway, the point would be is that 500 nanometers is the average light, visible light, 450, whatever. And so in the experiment, 500 nanometers is 1,000 average atoms. So the fact is the polarization is gigantic. It's 1,000 atoms of distance. Okay, so if you were going to make a filter, it would be, you'd have to have 1,000 atoms of difference. And it's only when you get less than 1,000 atoms of distance do you start breaking all the photons, and you don't get any through the filters. So you know that the photon has to be this very big thing, okay? It has to have a very wide polarization. So how can a single photon affect an electron that is 1,000,000 times smaller? How does something that gigantic hit a single electron? Or more importantly, how does a single electron in an atom move from here to here and create something that's thousands of atoms in size? No chance. All right, so that's what I'm saying with this simple question. A physicist should know. If a photon's polarization is many hundreds of atoms wide, how can it affect a single electron, or how can a single electron produce a photon? So I think it's a very important question for physics to answer, because it doesn't make any sense. Something 1,000,000 times bigger than the electron. How does the electron make something in space that has spatial dimensions that are 1,000,000 times bigger than it? How does it do that? Yeah. Okay, so then to the second question. If I crash an object of 10 mass and 5 velocity into a spring, so I should have written out mass because I wasn't under character restrictions here. But anyway, 10 mass and 5 velocity into a spring, and lock the spring at the greatest compression. So this isn't complicated at all, right? Then replace the object with a 5 mass object and release the lock. So this is all pretty simple, right? Will the object leave with twice the velocity and twice as much kinetic free energy? So it's a simple enough question, yes or no. All right, anyway, so this is his response. Meh, whatever that crap is. All these, you know, this big in nerd land going, meh. Anyway, you and I are different. Yes, I'm really interested in the truth and good arguments. Good arguments mean a lot to me. Yeah. I like to explore a topic, whatever, so that's more, you know, Pyrrho kind of philosophy. You know, you're here for my entertainment, okay? And, you know, I have my little explorer hat on, and I'm just here for the fun. I don't want to step in any serious quicksand. Anyway, explain where the mistakes are, and then try to use the mistakes to create an educational presentation. Well, you know, this whole idea of what the definition of educational is. You know, are you standing up for the truth, or are you just a propagandist? Because frankly, that's what most education is, right? If you look at most of what people are yammering to children, do you think any of it has any truth value? I mean, it's all lies and fairy tales and bullshit and happily ever after nonsense. So clearly, that doesn't seem the interest of most people. I mean, what they call an educational presentation in this world, I don't think you'd want to stake your life on any of that crap. So I don't think that should be what you're after. Okay, what you're after is to make a good argument. All right, the mistakes aren't important. Well, they're kind of fundamental and they have to be explained. So if somebody crashes a car because they stepped on the gas instead of the brake, I mean, you sort of have to explain it's really different, these two pedals. Very different functions. So you cannot ever ask the gas pedal to brake the car because it just doesn't understand when you say stop. And no, it doesn't understand, okay? It doesn't get it. So you can't do that. So you have to explain it. Anyway, what you can learn from it is. So I just ignored that crap because that's just mush. Anyway, I didn't even respond to it in my comment. In contrast, you just claim stuff is wrong and use personal incredulity to justify your position, which is just so, okay, I can insult you too. You're just ugly and flapping your anus and thinking that's your mouth. You then posit your own complete nonsense. So I could just say that about you, which has neither logical justification, so says you, okay, but you're not willing to show how it's not justified. It's perfectly, I mean, and all of this is justifiable in terms of arguing, right? I mean, all of these theories are highly under evidenced. Okay, their photon theory, their gravity theory, all of it highly under evidenced. It's not like they have this huge pile of evidence and they just sit there and flip pages of it and just show one. Hey, look, here's one piece. Here's a piece. Here's a photo of the round Earth. Okay, the globe from the moon. There, we're done. This isn't that kind of conversation, and you know it. So you're just pretending you have all this evidence and all these arguments have been made. No, they haven't. They're not in the historical record. This is just you hyperbole. All right. Nor experimental backing. It's not even wrong. So this line is just used over and over with these pretentious douches. I mean, it's not even wrong. It's just a way of dismissing and walking away. I mean, classic bullshit. And there should be a real crime for when you do say something like that and you're actually is just horseshit. I mean, it's just a horseshit insult, and you really haven't even tried at all to deal with the facts because there are all these issues. A lot of them are real subjects, and you're just, again, this is just your excuse for walking away. All right, the funny thing is that you are so obsessed with showing that people are wrong, which again is just more nonsense. I'm obsessed with the truth. That you missed the whole thing, which I could say just to him. I say that it should have pointed out a few other things. You say I should have pointed out a few other things. If you are capable of paying attention, then you would have realized that I did point these things out. So clearly he didn't say all the stuff that could have been said about the optical illusion that is the ferrocell. So it was way short of going through all the giveaways. And it was a tiny percentage of the video. Okay. The theory presented in the video is backed by overwhelming body of evidence. So this is just more of his hyper. Just like Ken Wheeler says, he's the only man who understands a magnet. Blah, blah, blah. This is just you doing the same thing. You don't have this mountain of evidence. Okay. Ironically, your comment is a piece of that evidence as it would not be able to post it without understanding the theory. So they think that if Faraday didn't choose to think field lines or where the energy is going through or something, that we wouldn't have invented the electric motor. Of course we would have. We already saw his work. We didn't need a theory once we understood why it happens. So once we understood that all you have to do is put electricity through the wire perpendicular to the magnetic field and it spins around, what do you mean? I don't need any theory. I don't care whether Gremlins did it or Abominable Snowman did it. Who cares what my theory is? So this is just more of these lies where they pretend we couldn't go anywhere if we don't believe in their multiverses. We can't do anything. We don't believe in the expanding universe. All this crap that has absolutely nothing to do with the existence of computers or any of this stuff. None of this crap theory was at all necessary. If their crappy theory worked, it wouldn't have taken them 20 years to develop the blue LED. It wouldn't have taken 20 years if they had a good theory. Okay. As for your questions, they are not even coherent. So, yeah, just whatever. Yeah, okay, you can't understand the logical connection of taking a heavy thing, moving and compressing a spring, and then removing the heavy thing and putting a lighter thing and then releasing the spring again. That's conceptually way too many moving parts. What's your problem? Oh, I mean, just too silly a response. I mean, just it's so obvious, just a dismissive evasion. Please don't take this as me being dismissive, patronizing, or derisive. Whatever. Your questions demonstrate that you do not even have the most basic understanding of the subject matter. So again, just way overdone, way overstated. These are legitimate questions. Photons are big, giant objects in space. They have to cover a whole bunch of space. They can't go through tiny holes. I make the hole small enough the photon can't get through it, and the hole that's small enough to block the photon is 1,000 atoms wide. It's a huge hole that it can't get through. That's a real subject shit for brain, especially when you're saying electrons make these things. That somehow the million times smaller electron, well, it's actually 1 billion times smaller. It's actually 1 trillion times smaller. That little thing moving somehow made this big giant object. Anyway, I cannot stress enough, you do not understand what you are talking about. Oh, says you. Oh, this is so pathetic. How can you know a theory is wrong if you don't understand it? So just more, I don't understand the multiverse. I don't know it's wrong just because there's absolutely zero reason to believe. I might as well believe in the Bugs Bunny-averse. There's just as much evidence for the Bugs Bunny-averse. Okay. In contrast, you just claim stuff that is wrong. First step in fixing what is broken is recognizing it's broken. So that's my reply. He says, and use personal incredulity to justify your position. I don't even know what personal incredulity even is. Okay? I mean, what does that even mean? I'm personally incredible? I mean, I don't know. I mean, that almost sounds like a good award. He's personally incredible. I don't even know what that could possibly mean. But anyway, I just said, that's just incredible mush, because what the fuck is that? Your mother wears army boots. There, are we done now? Ugh. I mean, it's so bad. I mean, these are smart people, and this is the best they can do in terms of an insult. Shit. Okay, then you posit your own complete nonsense, which they haven't demonstrated to be nonsense, which has neither logical justification nor experimental backing. And, well, it has just as much as you. Anyway, so this is my response. Most of the conventional religion you call physics fits this description. So yes, most of what they believe is unproven, undemonstrated. It's a mushy model, the Bohr model of the atom, all of this stuff is completely unproven, and it's full of, ooh, that doesn't sound quite right. Ooh, that doesn't work. Oh, that, it's full of stuff where it's like, oh, this really can't be the right answer. Okay, the resolution from space, I say this, the resolution from space is 400 times better. Why hasn't the Eddington experiment been repeated from space where there is also no dependence on an eclipse? So I should put a question mark there. But I mean, glaring example of you just talk, okay, not walking, okay? All this talk about your big evidence, and your evidence is really, 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 really thin. Okay, it's not even wrong. Anyone can say that about anything. So again, it's just more of this quippyisms that aren't even smart. I mean, they're just so, your mother wears army booty. I mean, it's just so bad. Ugh. The funny thing is that you are so obsessed with showing that people are wrong. So I say, I believe facts should be added carefully, okay? And paradoxes indicate bad addition. So when you find a contradiction in your factual addition, that's really important. Okay, when you're getting 2 plus 2 equals 4 over here and 2 plus 2 equals 3 over here, there's something wrong with what you're doing. Okay, so you have to fix it. And that's all over your physics. Okay, that you missed the whole thing. I believe you're doing that. So, I mean, obviously, again, everything he says to me, I could just bounce it back. Yeah, I'm rubber, you're glue, blah, 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 blah. You say that I should have pointed out a few things. I'm suggesting your video would have been more persuasive. That is, the people you're talking to are Ken Wheeler's audience, I would hope, and people who don't have a complete understanding of physics. So making a bunch of technical arguments about your theory, which doesn't in any way really connect to actually understanding why the pattern's being created. So it has absolutely nothing to do with why people are misunderstanding. Not having a magnetic moment theory is not why people are being fooled. So I'm just saying, for you to spend 10 minutes of the video talking about magnetic moments and then 3 minutes of the video talking about actual physical events was really, in my opinion, ludicrous. Okay, if it contained less theoretical jargon and more plain facts. So I'm saying, yes, it would have been more persuasive if you just forget the jargon, the magnetic theory. Talk about what the little filings are doing and why they're creating the illusion. Okay, if you were capable of paying attention, so just more nonsense. Obviously, I'm paying more attention than 99% of your audience, and it's a fact. I'm listening to your video. I'm paying attention to the theory you're arguing. I'm completely connected to it in terms of understanding what was said and what was missing. So, again, just such a ludicrously stupid thing to say to the people who are actually paying complete attention. Amazingly stupid. I mean, I would concede that some of my trolls pay more attention to the details in my videos than the people who are supportive of my efforts, and that's just the truth. Okay, adversaries often pay a lot more attention. Okay, more mushy accusations that have nothing to do with reality. So it just proves he's willing to posit theories that have no hope of being true. I mean, again, that is theoretically stupid, okay? It's a dumb thing for a lawyer to say because it's not going to make you look good to somebody smart enough to know better. As I stated, the last 3 or 4, he says, then you would have realized that I did point things out. So again, I didn't say you didn't point anything out. So again, I said, as stated, the last 3 or 4 minutes with a few additions would have been a much better video. So again, I'm just arguing that you should have just done without the 10 minutes of dead, boring jargon and stuck with the exciting bit at the end where you're, pulling the curtain back and showing the wizard behind the curtain. That's the part you should have focused on. And I have no idea why you thought it was a good idea to go into a bunch of magnetic moment jargon mathematical horseshit to impress who? All right. The theory presented in the video was backed by an overwhelming body of evidence. So this is it's just such a hyperbole, just such an exaggeration. No, it's supported by exactly the opposite, an incredibly empty, cricket-infested void of evidence. Okay, anyway, too bad none of the evidence is physical or real. You should learn the difference between lines of force and arbitrary field lines. So this is a really important bit. I've emphasized this so many times in previous videos, months and years back. But the key failure of Faraday, okay, and Maxwell. So these two people did kind of work together. I mean, Maxwell was kind of a young man when Faraday was a very old man, but much of Maxwell's work was based on Faraday's work. And so Maxwell, when he drew charge, completely got it brilliantly right, okay? I mean, if we draw charges, everything's radial like a sun, okay? And so all you're really doing is saying how many of these lines do you intersect? Do you intersect, and so if you're far away, you intersect very few. If you're very close, you intersect a lot of lines. And so that tells you the inverse square law, for one thing. I mean, it tells you the R law, and that you're going to get more radiation the closer you are and all that kind of stuff. But it's, yes, so, you know, and it's going in 2 dimensions. But anyway, I mean, it gets trickier when you get into dipole, so I don't want to get into when the r squared turns into the r cubed rule. But anyway, this is what charge is doing. So you're all just really counting is how many of these lines hit the other charge, and vice versa, and blah, 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 blah. And you decide whether it's repulsion or attraction, dependent on how many of these lines intersect each other. And that's what all the math is made out of. And so the critical error is when they move to magnetism, you know, they do this stupid field line thing, okay, you know, where the real radiation is a strength coming out, right? So you have a strength of light. So if this was red light and this was blue light, you could understand that it gets very purple here. And so that's why the magnet lines up, you know, this way here, and why it's this way here. Okay, so if you understand its attraction and repulsion, you understand why the blue end is here and the red end is here, and you understand why the blue end is here and the red end is here, because there's attractive force here and attractive force here to these ends, and then there's repulsive forces this way and repulsive forces this way, and that's what's creating the balance of this line. But this line has nothing to do with anything traveling through the lines, right? The lines are irrelevant. They're arbitrary. The real field lines are these lines. These are the lines of force. These are the lines that are telling the magnet which way orientation it's going to have. These are the lines pushing on the red side or pushing on the blue side this way. Those are the ones that are telling the magnet, twist, turn, do this, do that. The lines of force are doing the telling. They're the ones creating what the pattern of the little magnets will be. The pattern of the little magnets is being dictated by these lines of force. Huge mistake. Like I say, Faraday thought the field lines were the important lines, and stuff was moving through the field lines, and that's where, you know, the theory went bad. Because they're not arbitrary, but they're just a byproduct. They're an emergent consequence of the elemental function. The elemental function is the field lines, the radial lines. That's the elemental function. The lines, the lines of force. See, field lines. It's always confusable. The lines of force are these rays. Okay, so it should be the rays of force. Okay, those are the things that are elemental. Those are the things causing the effect. The emergent lines of force are just the alignment of the little magnets. They don't mean anything. They're just incidental to the primary function, which is the rays coming off the poles. Okay. Then you realize that just too bad no physical evidence. As stated, I don't know where I left off. It's just phooey. Let's see. If you were capable of paying attention, yeah, we definitely did that. Then you would realize I did point these things out, and I stated no. Yeah, the theory presented in the video is backed by overwhelming body of evidence. So that's the part, right? Okay, too bad none of the evidence is physical or real. You should learn the difference between real lines of force and arbitrary field lines. One is elemental, one is a real function, the other one is just a byproduct. It just emerges out of the elemental function. Ironically, your comment is a piece of that evidence, as you would not be able to post it without our understanding, without our understanding of the theory. So somehow he says we have to understand magnetic moments, or they wouldn't have invented the LCD, and they wouldn't have invented the computer, and everything, all our technology would disappear. Bullshit. All right, anyway, that theory is as under evidenced and unproven as the rest of your physics. So yes, the theory that we couldn't invent anything without having proper theory is just nonsense. Clearly, people were doing lots of metallurgy before they understood anything about atoms and all of that stuff. We invented steel long before we knew there was any such thing as an iron atom and any of that crap. So, it's just horse shit. All right. As for your questions, they are not even coherent. So I said monstrous evasion and cop out. I mean, it's just monstrous. They're real questions. My audience can understand them. So, I mean, your audience should be able to. Uh, just bullshit. All right. Please don't take this as me being dismissive, patronizing, or derisive. I say, no worries. I already have a pretty low opinion of your character, and you're just demonstrating you'll go a step lower, so no big deal there. I sort of I expected evasion. What else should I expect? That you're really going to take anything in science seriously? No, of course you're not going to take any of it seriously. That's the only way you can hold such a silly opinion and a silly perception of reality. Okay, you can't take it very seriously. All right, your questions demonstrate that you do not have even the most basic understanding of the subject matter. Again, just insane exaggeration. I think a classroom of 10-year-olds could understand the questions. They could certainly understand if I told them what polarization was of a photon, that it meant, see, it can't get through. If I make a bar this big, it can't get through the bar. And the bar size is 1,000 atoms. So you kind of have to understand the photon is in space. It's filling like 1,000 atoms worth of space. And an electron is 1/billionth the size of an atom. So exactly how the fuck does that single little tiny electron create this big, giant, humongous thing? All right. I think a classroom of 10-year-olds could understand the question, and I bet they would like to hear the answer. So I guess if I told a bunch of 10-year-olds, hey, they have this theory about energy, and if I push a spring with an elephant's butt, okay, so I have an elephant sit on a spring, and then I lock the spring, and then I put a bunny rabbit on the spring. Their theory is that the bunny rabbit leaves with twice as much energy. Go figure. I mean, not twice. 573 times more energy. Yeah, that's their theory. Okay. They'd want to know the answer. And I bet they would like to hear the answer. Anyway, I cannot stress this enough. And I said, yeah, you don't spell evade, S-T-R-E-S-S. Yeah, that's a pretty good joke. You don't understand what you're talking about. I think you do understand what you're evading. So it's pretty clear, right? So all these people make these arguments about conspiracy theories and all this crap and what I'm saying about science. Now, look, in the past, I think they were more honest. I think they were honestly excited about doing physics and excited about doing their little experiments. You know, the Madame Chatelates and the rest of them doing their little crappy science. I don't know if they really deliberately evaded, okay, because there wasn't somebody rubbing their nose in it and saying, well, what about, and what about, and what about, and what about, because they didn't have those people around them. Now, Voltaire and her had a big falling out over this, so I don't know, not Voltaire, what the fuck's his name? Well, whatever, doesn't matter. Yeah, Voltaire. Volta and Voltaire, you get confused. You have to watch what the brain's doing all the time. Anyway, so yeah, then you could sort of say, hey, wait a minute though. Clearly her enthusiasm was disproportional to what the science something should have been saying to her. I'm being too aggressive. I'm being too aggressive. I'm being too aggressive. I got to concede that only clay experiments show this, and that's not a good thing. Okay, I got to find better experiments if I'm going to keep saying this horse shit. So I'm just saying that this is, but what's the accusation here? Like I said, I can't make the question much simpler. The simple concept demonstrates the paradox. So you have to either admit that there's no conservation of momentum, or you have to admit that the kinetic energy theory is kind of silly. You really don't have a choice if you contemplate the experiment seriously. And what you just did is just horrific evasion. Anyway. So, I mean, what am I supposed to say? Oh, you're really telling me he couldn't figure out what the question was asking? Or what it was demonstrating? Or is he evading having to take a position? Okay. How can you know a theory is wrong if you don't understand it? The history of the kinetic energy theory is as bad as Ken Wheeler physics. So I can always know when somebody's doing bad science. So when Ken Wheeler smashes a plastic bottle against a wall, and it's obviously hard plastic, and the plastic is obviously dimpling up in the inside, right? So when he's pushing the bottle, it's obviously creating a dimple on the inside, and then says, look, it's a magnetic rings, and it says all this horse shit. I mean, it's obvious horse shit. Okay, so yeah, and I'm saying that your theory creates the same kind of obvious horse shit. I know the world runs on big, giant, heavy wrecking balls, that they're not using lighter ones, even though the kinetic energy theory says you're much better off with lighter ones. You'll make much more building fall down if you use a lighter wrecking ball. That's the implications, the direct implications of the kinetic energy theory is lighter is better. Get as small as a bullet and you can have so much more energy. Okay, go really fast and be really light and you'll have so much more energy. That's the truth of your theory, and it doesn't fit the reality. All right, and so I can know that. I can see the paradoxes, just like your twins, relativity argument. Well, which twin is actually moving? One of them actually has to be doing the actual, speed of light type velocity. Because if they're both not moving the speed of light, then they're both going to age more aggressively or slowly. Well, anyway, it creates paradoxes, and you just want to pretend they don't exist. It is as mushy as the clay used to quote mind, the clay used in the quote mind experiment. So I thought that was a really good line. It's totem pole science. All right, then some douchebag chimes in, which all too often is the case. You fail to realize that you are just Ken Wheeler version 2.0. Yeah, except I'm begging to debate people like you. I'll debate you anytime, any place, buddy. Okay, Ken Wheeler won't do that. Okay, unlike Ken Wheeler, I'm willing to debate anyone regarding the credibility of the arguments I have made. Very much unlike Ken Wheeler, I'm willing to pay a science channel with more than 100,000 subscribers $2,000 to attempt to debunk my physics. Let me just play my 12 minutes of video. Give me 12 minutes of your audience's time. All right, and I'll create enough doubt in their brain to haunt you for the next 20 years, frankly. Okay, they'll start asking you a lot of questions. Okay, like Ken Wheeler, your science hides from interrogation. So it's you people who are the ones afraid of simple questions. I mean, are the questions what? You didn't understand the questions either? I can send you to Quora, okay, a bunch of other questions written by other people. They're just asking simple questions about kinetic energy, and not a single one has been answered with anything called reasonable arguments. Ask a simple question, get gibberish and evasion. So anyway, all right. So, I can just do my side of this job. So another thing, I don't think I'm going to be bothering with the Stephen Bro comment responses. He just makes so many silly accusations. So one of his new accusations is that he has to spend so much time watching my videos and he has to reply and blah, 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 blah. I mean, I've made on purpose. So, on the website, the videos are right there on the website. I mean, what's fooling you here? Okay, it's just not that complicated. You just go past the most recent video, and you read this little bit, and right here, there's 3 videos, and they're all under 20 minutes long. I think all under 17 minutes long, but whatever. What is energy? The sensible answer. What is gravity? The sensible answer. What is a photon? The sensible answer. Those are the only 3 videos you have to respond to. Just 10-minute, 12-minute videos. That's what you should be responding to. All this game playing you're playing with, I'm going to go back to some time where he made a typo or where he said something wrong, and you're just going to pick on these tiny percentages of my argument. These are my arguments. These are my arguments, boiled down to what I want you to respond to. Just as I wish you would make some kind of coherent video where you actually ask a question instead of claiming I didn't answer a question. When, go ahead, ask me this brilliant question you have, and I'll answer it. But you don't do any of that. You're just a harassing jackass who just wastes everybody's time with your buffoonery and your accusations for which you have no evidence. This moron is still making the accusation that my internet wasn't disrupted for a week. I mean, it's just so fucking idiotic. I mean, I'm not going to, dox myself by proving it, but I'm just saying it. It's where does he have any reason to doubt? No. Is there any evidence, circumstantial evidence? No. Is there anything to base it on except him wanting to lie? No. So if I just make up a story about what you do when you're babysitting for your crack whore friends, is that legitimate? Did I just put in people's minds some reason to doubt whether, oh, just look at that guy. Would you leave your kids with him? Do you think he's really just telling nursery rhymes? Or do you think he's, playing a little, whatever, pocket billiards and shit? I mean, what right do you have to imply this crap when you have zero evidence to back it up? I mean, just absolutely zero evidence. It's just so fucking obnoxious and rude. And then this asshole complains that somebody's been rude to him in the world. If you've gotten a hard time from somebody, you've gotten exactly what you deserve because you're a little piece of manipulating scum. Fuck you. Nobody could do you any wronger than you've done the world. You're a dishonorable lying puke. Ugh. Anyway, shouldn't even talk about it. So still no big evidence video. Again, it's going to be a farce. We can already know that he's just not going to resist turning it into farcical crap. Because if he does a serious video, he's going to be stuck being humiliated. Because his science is going to suck. Ugh. Anyway. God, I just hate this planet of so many assholes. So, I don't have to do that. Whatever my reflex is to grab that thing and move it for some reason, I don't know why that exists. But anyway, so this has been a DraftPhysics.com video presentation. Till the next time.